parametric equations. Okay, parametric equations. So what's going on here is this is another system. All right, so up to this point, everything that you've done in math has been in the rectangular system with x's and y's. Then we introduced the polar system not too long ago. So that had the r's and the thetas. Well, the parametric system also involves x's and y's, but it introduces a third variable. 9 times out of 10, it's time, especially when there are some application problems. It's usually an application of time. But essentially what it is it's kind of a system of equations. You're going to be given 2 equations. So in the first example here, you can't see that. The first example you have on your paper, x of t is equal to 2t, y of t is equal to t squared. So those are what we consider the parametric equations when they're put together. Okay, those are the parametric equations. The parameter is the variable that shows up in both equations. So in this case, the parameter is the variable t. Now, there are several things that you'll be asked to do with this. Sometimes you'll be asked to plug in values. Sometimes you'll be asked to solve for values. It just kind of depends. So I'm going to show you from a couple of different perspectives. The first one that we're going to do here, we're going to find the x and the y value when t equals 3. And it really is just that simple. We are plugging 3 into our x function for t. So the x is 6. The y of 3 is 3 squared, which is 9. So your answer would be the coordinates 6, 9. When t equals 3, the x is 6, the y is 9. All right, now something else you may be asked to do is to eliminate the parameter and write y as a function of x. So what we're going to end up doing is we're going to end up substituting. Okay, we're going to substitute. So eliminate the parameter, that means the parameter is t. We're trying to get rid of the t. We're going to substitute to get rid of the t. So what you need to do is you need to look at your 2 equations and decide which one is easier to solve for t. So I'm just going to rewrite them so that I'm looking at them here. I'm just going to rewrite x is equal to 2t, y is equal to t squared. I'm just leaving off the function notation with the x of t, just writing the x is the same difference, okay? So which of those 2 equations would be easier to isolate the t variable? The x one or the y one? X, right? All we have to do is divide by 2. X over 2 is equal to t. So since that quantity is equal to t, we're going to plug it in for t in the other equation. So t was being squared, so we're going to square the x over 2. So that says that y is equal to square the top, square the bottom. X squared over 4. We have eliminated the parameter, and we have written y as a function of x. X is now the variable in the y equation here. All right? Simple enough, right? Questions? Sometimes they like to use trig. So let's look at another example here. We have x of theta this time. X of theta is equal to the sine of theta plus 2. Y of theta is equal to the cosine of theta minus 3. This time our parameter is the theta. Okay, it's all about which variable do both of the equations have. They both have theta, so theta is our parameter. We want to find the value of y when x equals 2. So this is kind of turned it around a little bit. In example 1, they told us the value of t, so we just plugged it in for t. Now they want the value of y when x equals 2, so we're not plugging this in. It doesn't say theta is 2, it says x is 2, so we're going to set our x equation equal to 2. So 2 is equal to the sine of theta plus 2, and we're going to solve for theta. Good opportunity here to review some trig. We have to get the trig function by itself, so we subtract the 2, so 0 is equal to the sine of theta. Now the question is, at what angle is the y-coordinate 0, because sine is the y-coordinate. So the y-coordinate is 0 at 0 and at pi. You could also include 2 pi, but just remember 2 pi and 0 are the same thing. So we found theta. We still haven't answered the question though. It says find the value of y. We have 2 options for theta, so we're going to have 2 answers for y. So y of 0 is equal to the cosine of 0 minus 3. The cosine of 0 is 1. 1 minus 3 is negative 2. So that is one answer. Our other option was that theta could be pi. So the cosine of pi minus 3. The cosine of pi is negative 1. Negative 1 minus 3 is negative 4. So just because it was trig, we had two possibilities here. Questions about that? Now, we're going to do the same thing that we did in example 1. We're going to eliminate the parameter to write it in rectangular form. So we want it just in x's and y's. We don't want that theta in there. But there's a little bit of a difference here. Because we are not just going to solve one of these equations for theta, because if we try and do that, we're going to end up with inverse trig, and that's just not the way we want to, the direction that we want to go in, okay? So again, I'm just rewriting my equations so I can see them. You've got them right there. So here's what we're going to do. Instead of solving one of these for theta, because again, it would involve inverse trig, what we're going to do is we're going to isolate the trig function in both expressions. We're going to isolate the trig expression in both functions. So we're going to subtract the 2 from the x and get sine by itself. We're going to add the 3 to the y and get the cosine by itself. Now what we're going to do, we can't substitute because we don't have sine in the other equation. We don't have cosine in the other equation, so we can't do any substituting. So here is the next step, and it's going to look kind of weird, but this is the way that it goes whenever there's trig involved. We are going to square everything in both equations. We're going to square it. Square both sides of both equations. Now, we're not going to FOIL it out. We're going to leave it as x minus 2 squared is equal to sine squared of theta. And I'm going to do something here. I'm going to write this one below it now, because what happens next is we're going to add these two equations to each other. So we're going to add the left side, we're going to add the right side. So we've got x minus 2 squared plus y plus 3 squared is equal to sine squared theta plus cosine squared theta. Now you're probably thinking that I'm just making this problem bigger and bigger and bigger, and I'm not getting anywhere closer to getting rid of theta, right? I don't blame you, because it is getting bigger, but it's about to get smaller. What's sine squared plus cosine squared equal to? 1. Sine squared plus cosine squared is equal to 1. I know we covered that in the trig unit, but it's always true. It doesn't matter whether you're in the trig unit or whether you're talking about parametric equations or what you're talking about. If you have sine squared of theta plus cosine squared of theta, it is always equal to 1. So now we're done. That is it. That is the equation in rectangle. We got rid of the parameter. The parameter was theta. Theta is not in our equation anymore. We've just got x's and y's. Now, we just got done with our conic section unit. What is that the equation of? circle. This is a circle centered at +2, -3 with a radius of 1. Now let me show you in your calculator how parametric mode works. Okay, go to mode. We've used function, that's the normal. We've used polar. Well, the one in between function and polar is parametric. PAR stands for parametric. So change it to parametric mode, and then when you go to your y equals, it's changed again. X sub 1 of t, y sub 1 of t. That gives you the place for your x equation and your y equation. So if we type in sine, notice when you use the x button, now it puts a t. Now I know our equation had theta, but I mean, it's the same difference, okay? Because usually in parametrics, your parameter is t. So you can type that in, type in the x, type in the y, and graph it. And it doesn't look like a circle right now, but again, my window is not square. So if I do zoom square, there's my little circle. Centered at +2, -3, little bitty tiny radius of 1. So parametric mode, again, I can graph this by hand if I remember the properties of circles and stuff, but I can't graph this in my calculator very easily. I would have to get y by itself. I'd have to move this over, take the square root, subtract 3, make sure I get parentheses in the right place, remember my plus and my minus because I took the square root. You don't want to have to do that. If you have it in parametric mode, it's a whole lot easier to make the calculator graph a circle. Or in polar mode. If you have those equations, your calculator can graph those a lot easier than graphing that in rectangular mode. All right, questions about that? We're going to do some more we're going to do another example with the sine and cosine here in a minute. All right, so let's go back to one that doesn't have trig. Let's just use some basic equations here. X of t is equal to the square root of t, y of t is equal to 3t plus 1. Again, t is the parameter here. I don't think they're going to ask you a question where they ask you what's the parameter of this equation. That's too easy. I just mentioned that so that you get used to that word parameter and what does it actually mean in the equation. Okay, so don't be thrown off by the vocabulary is my goal there. Part A says find the value of x of t when y of t equals 13. So again, they're giving us a condition. They're giving us that one of the equations is equal to something. And we got to find what the other equation is equal to at that same time. So y of t is equal to 13. So we set 13 equal to 3t plus 1. When we solve that, we subtract the 1 and we divide by 3. So that says that's at time 4. We want to find the value of x of t at that time. So x of 4 is the square root of 4, which is 2. So the time is 4, but the actual answer to the question is 2. Let's write this one in rectangular form. So x is equal to the square root of t. Y is equal to 3t plus 1. Which one do you think we should solve for t? X or y? Okay, I've heard somebody say y. You could. Anybody think we could solve the x one? What would we do to get t by itself for the x equation? Square it. Now, solving the y for t is not a big deal. It's not. But they want us to write y as a function of x. So if we solve the y equation for t and plugged it into the other one, then we would have to get y by itself over there as well. So it's really easier to solve the x function. So that is our t. So y is equal to 3, not t anymore. T is equal to x squared. So we substitute it. Now we're done. Now we are finished. So I find it kind of interesting that in parametric form, we have a square root function and we have a linear function. And in rectangular, what's the word I'm looking for? Totally lost it. System, that's what I'm looking for. Rectangular system, that's a quadratic equation, okay? So in the polar system, we have a square root and a linear, and in the rectangular system, those two together end up giving you a quadratic. Kind of interesting. All right, let's do one more of these trig ones so I can show you again. We've got a parameter of theta again. This one says find the value of xy when theta equals 3 pi over 2. So this is the easy case. We're just plugging that in to both equations. Good review of the unit circle. What's the cosine of 3 pi over 2? Zero. Yeah, y'all knew that, right? The y of 3 pi over 2 is 4 sine of 3 pi over 2. Anybody know what the sine is now? -1. Think about where 3 pi over 2 is. 3 pi over 2 is at the very, very bottom. So if the cosine is 0, the y is -1. So the xy here is 0, -4. So that's what your calculator is doing when it graphs in parametric mode. It's taking various values and plugging them in and getting the x and y and plotting that point. So we could have done it for 0. We could have plugged in 0, we got the x and the y, we plot that x and y point. Once you plug it in, the value of the parameter doesn't matter anymore. The 3 pi over 2, that doesn't show, that's not reflected on the graph. What shows up on the graph is the x and the y, okay? All right, let's eliminate the parameter to write this one in rectangular form. So similar idea, we've got x is equal to 3 cosine theta, y is equal to 4 sine theta. When trig is involved, you want to isolate the trig function. So this time we're dividing because we were multiplying. Anytime the trig's involved, or after we isolate the trig, we go through and square everything. And then we're going to add them together. So we've got x squared over 9 plus y squared over 16 is equal to cosine squared theta plus sine squared of theta, which is, of course, equal to 1. What are we talking about here? All right. What kind of shape? It's equal to 1. There's a plus. Ellipse. Thank you. It's an ellipse. Is it taller or is it wider? Taller. Because y is over the bigger number, so you go further units away from the center to plot your vertices. You don't go as many units away in the x direction to plot your co-vertices, so it is taller. It does have a center. This one's easy, 0, 0, because you're not adding or subtracting anything from your x or your y. Okay, maybe we should spend a little bit more time on the comment section. All right, almost done. Let's look at a word problem. 2 rockets are fired from a space station. The first rocket's path can be described using the parametric equations x of t equals t plus 4, y of t equals 3t minus 1. Second rocket's path is x is equal to t plus 4, y is equal to 2t plus 9. Eliminate the parameter for the equations given for the first rocket and express its path as a function. So looking at the first rocket, which one is easier to solve for t? I agree. I think the x is easier to solve for t because we just subtract the 1. We plug that into the y equation. We want to distribute and combine like terms. So 3x minus 12 minus 1, 3x minus 13. Part B asks us to do the same thing for the second rocket. Well, for the second rocket, the x component is the same. So I'm going to solve the x component. For t, I should get the same result because it was the same equation, and plug it in to the y. So this time when we distribute, we get 2x minus 8 plus 9, so 2x plus 1. So these are the 2 equations for the rockets in function or rectangular form. Now, part C asks, will the 2 rockets collide? Defend your answer using mathematical reasoning. So any thoughts on how we can figure out if these 2 rockets are going to hit each other? Graph it, okay. What are we looking for on the graph? Where they intersect. Can I find the intersection without graphing it? Set them equal to each other. If the 2 equations equal each other, then it probably makes sense at some point in time that they are going to hit each other. If we solve this for x, subtract the 2x, add the 13, we get x equals 14. Let's solve for all the other pieces. Let's see what time that would be. So the x minus 4 equals the t. So that's occurring at time 10. And what would be the y value? We could plug it into either one. I'm just going to go to the first one. They both should give me the same result. 3 times 10 minus 1 is 29. I'll plug it into the other one. 2 times 10 plus 9 is 29. So here's my reasoning. Yes, at time 10. Did it give me units? No. So we'll just say at time 10, location 1429. At the same time, at time 10, they both have the same x and y coordinates. So yes, they do collide. All right, let me show you one more with the eliminating the parameter that has to do with trig, but it's not sine and cosine. So we still need to do the same thing. We need to get our trig functions by themselves. The first one is by itself. In the y equation is not, so we need to divide by 4. And then second step is to square it. So we get x squared is equal to secant squared t. I don't want to write that right there. I want to write it here. Y squared over 16. Because I squared the y, squared the 4, is equal to tangent squared of t. So when it was sine and cosine, sine squared of theta plus cosine squared of theta was equal to 1. Is secant squared t plus tangent squared t equal to 1? We don't know because we don't remember. Right? So let's see here. To get secant is 1 over cosine. So I divide everything by cosine. Sine squared over cosine squared is 1. No, it is not. It's tangent. Getting ahead of myself here. That's tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. I'm wanting to get rid of the variable, so I need everything on one side. So that's what? Secant squared minus tangent squared. Secant squared minus tangent squared. So I need to subtract these two equations. So we get x squared minus y squared over 16 is equal to secant squared minus tangent squared is 1. What conic section? Hyperbola. It's the only one with a minus. Hyperbola. Centered at 0, 0, because we're not subtracting anything from our x or our y. Let's see here. It's opening left and right because the x squared comes first. And that's all I'm going to do for that.